السلام عليكم. اهلا بيكم حبايبي طلاب OL إدكسل اللي عندكم امتحان بكره. احنا ان شاء الله النهارده هنعمل ريفيجن، والريفيجن دي هتساعدكم ان انتوا تجيبوا A * في الامتحان. انا معاكم دكتور احمد عيد، وان شاء الله النهارده هنعمل ريفيجن على كل اجزاء المنهج. طيب خلينا نتكلم الريفيجن بتاعتنا هتكون متقسمه ازاي او هتتعمل ازاي. مبدئيا كل فيديو هيكون مدته حوالي نص ساعه، هنعدي على كل جزء في المنهج عندك الأجزاء المهمة، بس هقولك تذاكرها ازاي، هقولك الحاجة المهمة فيها. كل اللي هتعمله ان انت تتابع معايا الفيديو للنهاية، تتفرج على النص ساعة اللي هتنزل دي، وبعد كده بعد ما هتخلصه هتلاقي نزل فيديو تاني، وهكذا تفضل تتابع لحد ما نخلص المنهج كله. ان شاء الله النهاردة هنعدي على كل أجزاء المنهج، دي هتبقى مراجعة شاملة لكل حاجة. any part you want to review هتلاقيه موجود في الريفيجن بتاعتنا. طيب احنا هنبدأ من البداية خالص وهنكون ماشيين بالترتيب. الفيرست بارت من الريفيجن بتاعتنا Principles of Chemistry. Let's start with first lesson States of Matter. You have to know the main differences between solid, liquid and gas. When we talk about arrangement, solid particles are close together in regular arrangement. For liquid, particles are close together but in irregular arrangement. For gas, particles are far apart, also irregular arrangement. He may ask you about motion. When you talk about motion, in case of solid, vibrate about fixed position. In case of liquid, particles slide past each other slowly. In case of gas, random motion and rapidly. When you talk about shape, in case of solid, fixed shape. In case of liquid, it takes the shape of container. Also, in case of gas, no fixed shape, takes the shape of container. When we talk about volume, solid fixed volume, liquid has fixed volume also, while in case of gas, no fixed volume, it expands to fill its container. When you talk about arrangement, in case of solid, as you can see, regular arrangement. For liquid, irregular but close together. This is considered as the arrangement. In case of gas, he may ask you to draw one of this. When we talk about intermolecular forces, very strong in case of solid, weak in case of liquid, and very weak in case of gas. For compressibility, solid cannot be compressed, liquid difficult to be compressed, while gas easily compressed. Diffusion, difficult in case of solid, slowly in case of liquid, but rapidly in case of gas. Also, when we talk about energy, lowest energy in case of solid, moderate energy in case of liquid, and highest energy in case of gas. Let's start talking about interconversions of states of matter. As you can see in this diagram, from solid, let's start from solid to liquid melting, from liquid to solid freezing, from liquid to gas evaporation, from gas to liquid condensation, also from solid to gas directly sublimation, and from gas to solid it's called deposition. Let's talk about this part. If you have solid and put in energy in the form of heat, melting takes place and it converted into liquid. If you cool liquid, energy taken out, freezing may occur. Also, when we talk about liquid and the energy put in, heat in the form of heat, boiling may occur to give gas, gas condensing by cooling to give liquid. Solid can be heated directly by sublimation into gas, and the gas converted into solid directly by process called deposition and by cooling. So, if a solid is heated, its particles gain energy and vibrate more, so solid expand. He may ask you to explain this part. If a solid is heated, its particles gain energy and vibrate more, so solid expand. At the melting point, particles vibrate so much that they can now slide over each other and become a liquid. Take care that melting point and the freezing point of any given substance are both occur at the same temperature. So if you check this diagram, ice melts at 0 and water, liquid water, freezes or solidifies at 0 also to give ice. In this direction, heating, particles gain energy from ice to water, liquid water, and as you heat, it evaporates, then it boils at 100 degrees to give steam, gas. And as you cool down steam below 100, the water vapor begins to condense or liquefy to give water, then water cooled again at 0 to give ice. In this direction, cooling, particles lose energy, move more slowly as they get closer together and the forces of attraction take over. Let's talk about this part. If a liquid is left with its surface exposed to air, it evaporates. Look at this. If liquid left exposed to air, with its surface exposed to air, it can be evaporated from the surface. Evaporation takes place from the surface of the liquid. The larger the surface area, the faster the liquid evaporates. Also, evaporation occurs at any point, while boiling occurs at certain temperature. When we talk about boiling point, it's the temperature at which the liquid converted into vapor or gas. When liquid is heated, its particles gain energy and move faster, so liquid expand. Also at boiling point, all particles gain enough energy to overcome the forces holding them together and break away to form gas. Condensation is considered as reverse of evaporation and occurs by cooling. If a gas is cooled, its particles lose energy as we just mentioned and slow down their motion, so attraction between them holds them as a liquid. When we talk about sublimation, it's conversion of solid to gas directly without passing liquid phase. When we talk about deposition, conversion of gas to solid directly. He may ask you to work out the physical state of a substance at a particular temperature. A substance is considered as solid at temperature below its melting point. Below its melting point, let's say melting point of lithium 180, for example. So room temperature right here, below its melting point, so lithium is solid. If the room temperature or the given temperature between melting and boiling, so the substance is liquid. Look at this, room temperature between melting and boiling of bromine. So bromine is considered as liquid at room temperature. If the given temperature or even room temperature above the boiling point, it's like oxygen melting and boiling by minus value, so it's less than room temperature, so oxygen is considered as a gas. We can make test for purity. A pure substance has definite sharp melting point and boiling point. These are different for each substance. When a substance contains an impurity, its melting point falls, decrease, and its boiling point rises, increase, or it melts and boils over a range of temperature, not sharply. The more impurities it has, he asks question about this part in the last modular exam. The more impurities it has, the bigger the change in melting and boiling point, or the wider the temperature range over which melting and boiling occurs. When we talk about diffusion, diffusion is considered as spreading out and mixing process. It's considered as random movement of particles from region of high concentration to region of low concentration. It moves randomly. Take care of this. Diffusion does not take place in solids. Also, diffusion in liquids is much slower than in gases. Let's take some examples. First one, potassium manganate 7 It's considered as purple crystal which diffuse in water. At the beginning, dissolving must occur. The spreading of solute through the liquid is considered as example of diffusion, and the particles in liquid move more slowly than particles in gas. Let's check this image. First one is considered as diffusion of potassium manganate 7 as it dissolves. Once it dissolves, it diffuses. Second picture is considered as solubility or spreading of solute throughout the liquid. It's considered also as an example of diffusion. When we talk about bromine is red-brown liquid which is volatile, easily turns into gas without heating, so its fumes diffuse to fill gas jar. Let's check this. At the beginning, air right here and bromine right here. After removing the red, bromine spread, diffuse to fill gas jar. The other experiment is white cloud of ammonium chloride NH4Cl formed close to HCl as ammonia diffuse faster because it is light in mass. Ammonia molar mass is 17 while HCl molar mass is 36.5. So if we use this tube, look at this, if we use this tube and put cotton wool soaked in ammonia solution right here and cotton wool soaked in hydrochloric acid right here, HCl gas will move in this direction, NH3 gas will move in this direction. As you can see, ammonia move further because it moves faster, and the white smoke formed close to HCl because it's slower moving. The last part and the most important part in topic 1 is considered as the solubility of solid. When solid dissolves in a liquid, the substance that dissolves called solute, the liquid that dissolves in called solvent, and the final liquid formed is called solution. For solubility to occur, attraction forces between solvent and solute must be strong enough to overcome solvent-solvent attraction and solute-solute attraction. Let's define solubility. What is meant by solubility? He may ask you about this. It's the mass of solute which must dissolve in 100 grams of solvent at a particular temperature to form saturated solution. Again, mass of solute which must dissolve in 100 grams of solvent at particular temperature to form saturated solution. For example, the solubility of sodium chloride in water at temperature 25 is about 36 grams per 100 grams of water. What is meant by saturated solution? It's considered as a solution which contains as much dissolved solute or solid as possible at a particular temperature. There must be some undissolved solute. Look at this. That's the picture of saturated solution. As you can see, some undissolved solute present here. Let's talk about investigating the solubility of a solid in water. A procedure we can use to measure the solubility of potassium nitrate, for example KNO3, in water at 40 degrees Celsius is as follows. He may ask you about this experiment. He loves to ask about experiments. First part, weigh an evaporating basin. Heat a boiling tube of water to just above 40 degrees Celsius. يبقى at the beginning we just weigh evaporating basin was empty at the beginning, then heat a boiling tube of water just above 40, add potassium nitrate to the water in the boiling tube and stir rapidly until no more of it will dissolve and there is undissolved solid left over. Take care of this excess to make saturated solution. Allow the solution to cool to exactly 40 degrees Celsius. Pour off some of the solution into evaporating basin. It is important that you only pour off solution and no solid. You do not have to pour off all the solution, part of it. Weigh the evaporating basin and contents. Heat the evaporating basin and content gently to evaporate off all the water. When it looks as if all the water has evaporated, weigh the evaporating basin and contents. Heat the evaporating basin and content again and then reweigh. This is to make sure that all water has indeed evaporated, and this is called heating to constant mass. So steps from 1 to 3 right here. Water with dissolved potassium nitrate, temperature slightly above 40 degrees Celsius, then cool to exactly 40. Pour off some of the solution, no solid. Previously weighed evaporating basin, that's the mass, and find the mass of evaporating basin and solution, then heat, then find the mass of evaporating basin and solution until the mass is constant. We heat the solution gently to make sure none spits out. If some spits out, dead spit out, we would record a lower mass of solid. He may ask you about this. Why you record or why this is chosen to record lower mass? Some of it may be spit off. And the solubility would appear to be lower than the actual value. Let's talk about calculations. The results for experiment could be mass of evaporating basin 25.72, mass of evaporating basin plus solution 58, mass of evaporating basin plus dry crystals 38. We can calculate the mass of solid, just 38 minus empty basin, mass of solid, and we can calculate the mass of water, 58 minus 38. Now we have both of them. As you can see, 12.28 gram of solid is the maximum mass that dissolves in 20 gram of water. We have to multiply it by 5 to get 100 gram of water, so multiply this value also by 5 to get the solubility of it. It's 61.4 gram present in 100 gram of water, or you can use this formula. Solubility gram per 100 gram is considered as mass of solute, which is in this case 12.28, divided by, I will write it for you and you check it, 12.28, and mass of solvent, which is 20 in case of water in this case. Multiply 100, you will get 61.4 gram per 100 gram of water. Use this formula is preferred. Let's start talking about solubility curves. The solubility of solid changes with temperature, and you can plot this on a solubility curve. Most solids have solubility curves like this, as you can see in the figure below. The solubility increases with temperature, either dramatically like this or just a little like this. You can use solubility curve to work out what mass of crystals you would get if you cooled a saturated solution. Consider the solubility curve for potassium nitrate KNO3 at 90, let's check, at 90 degrees Celsius, 90 degrees Celsius for potassium nitrate, 200 gram of potassium nitrate dissolved in 100 gram of water. At 30, let's check, at 30, 50 gram of potassium nitrate dissolved in 100 gram of water. So, if we have a solution containing 200 gram of potassium nitrate dissolved in 100 gram of water and let it cool down from 90 to 30, 150 grams of potassium nitrate must be released from this solution, which it does as crystals. we say that potassium nitrate crystallizes out of the solution or precipitated out of the solution. Take care that because solubility varies with temperature, you must always quote a temperature with solubility value. The solubility of sodium chloride at temperature 30, for example, is كذا. Let's take example. The table shows the solubility of potassium chloride at various temperatures. As you can see, 10, 30, 40, 70, 90, and so on. Solubility values per 100 gram of water. First step, plot a solubility curve for potassium chloride. Use the solubility curve to find the solubility of potassium chloride at 50 degrees Celsius. At 50 degrees Celsius, solubility is 42.5 gram per 100 gram of water, as you can see. Second part, the maximum mass of potassium chloride that would dissolve in 50 gram, take care of this, 50 gram of water, not 100, at temperature 40. Let's check. At temperature 40 gram dissolved in 100. 40 gram in 100. But he asked about 50 gram of water. Half the mass of water. So, half the mass of sample solute, which is potassium chloride in this case. So, half as much, 20 gram, will dissolve in 50 gram of water. The numbers we used here, quite simple, as you can see, but if he told you maximum mass that dissolve in 34.6 gram of water, 34.6, so you can use formula. Mass of water divided 100 multiply solubility. Let's say solubility, we get 40, mass of water 34.6 divided 100, so we now found that 13.84 gram of potassium chloride dissolves. Third part, the temperature at which crystals will first appear if you cooled a hot solution containing 51 gram of potassium chloride in 100 gram of water. 51. Okay. Solubility measures the maximum mass of potassium chloride which will dissolve in 100 gram of water at particular temperature. Crystals will start to appear as soon as the solution becomes saturated. From the graph, it can be seen that more than 51 gram of solid will be soluble at 90. Let's check. 51, more than 51 will be soluble at 90, but at temperature 80, it will start to crystallize. So let's check together. Draw line at 51 gram, the maximum mass that will dissolve at 80 degrees Celsius, as you can see. So crystals will first appear at the temperature below 80. As you can see, 51 gram, cutting the curve right here to get 80 degrees Celsius. So the first temperature at which crystals will appear is below 80. What mass of potassium chloride would crystallize from the solution B(III) if the temperature fell to 10? He want to change the temperature or lower the temperature to 10. Let's check. At 10 temperature, the solubility is about 31. At 10 temperature, it's about 31. At 90, for example, is about 50. 51, for example. So we have to write it 31.2 gram at 10. And 51 is the solubility. The rest of it must have formed crystals. So 51 minus 31.2, 19.8 gram of potassium chloride will crystallize out. And now we finished first topic. زي ما اتفقت معاكم احنا هننزل مراجعة على كل التوبكس. كل اللي مطلوب منك بعد ما خلصت التوبك ده هتستنى مش كتير، لان انت يا دوبك اول ما هتخلص الفيديو هتلاقيني نزلت لك التوبك اللي بعده اللي هو Elements Compound and Mixture. بس خلص انت الفيديو واستنى الفيديو الجديد هتلاقيه نازل على طول. ان شاء الله النهارده هنراجع كل اجزاء المنهج. شد حيلك معايا واتفرج على الفيديو اول باول، ما تراكموش عشان تقدر ان انت تتابع معايا لحد النهايه، لان احنا ان شاء الله النهارده هنشرح بارت 1 كله، بارت 2 كله، بارت 3 وبارت 4 حتى اللي هو جزء الاورجانيك. بارت 3 هنتكلم على الانرجيتكس، فتابع معايا وان شاء الله هتلاقي مراجعة هتفيدك جدا وهتساعدك ان انت تجيب ستار بكرة. شد حيلك، اشوفك على خير، استنى الفيديو الجاي، ما تروحش بعيد عن الشانل. اعمل طبعا سبسكرايب في الشانل عشان تشوف الفيديو اول ما ينزل وعشان يحصل لك او يجيلك نوتيفيكيشن. برضه هتلاقي في الديسكريبشن الجروب بتاع التليجرام ده، انا هنزل عليه الفيديو اول ما اخلصه. كل فيديو هينزل على جروب التليجرام، فانت كل اللي هتعمله عشان تبقى متابع على طول مجرد ان انت تشترك في القناة، تفعل الجرس بتاعها وتشترك في التليجرام جروب، لان انا هنزل الفيديو في التليجرام جروب. هتلاقي اللينك بتاع التليجرام في الديسكريبشن بتاع الفيديو. يلا مستنيكو، هنبدأ الفيديو التاني بس تكون انت خلصت ده. سلام عليكم.